In this video, we're going to practice identifying functional groups and also the family that a molecule would be part of based on the functional group that it contains. So let's go ahead and start. What I would do if I were you is try this on your own first. So pause the video, and then afterwards, when you're done, you can unpause the video to check your work and assess yourself and provide yourself with some feedback. So let's start with this molecule over here. As you can see, we only have an OH. So if I didn't know this off the top of my head right away, I could refer back to the functional group chart and find the OH functional group, which is right here. That's called the hydroxyl functional group, and it makes you part of the alcohol family. So this is the hydroxyl functional group, and it makes this molecule here an alcohol overall. All right, let's take a look here. So here we have an OH, but you have to be careful. Notice that it's not just an OH, it's an OH connected to this C-double bond over here. So this we know is a carbonyl group connected to a hydroxyl group. So carbonyl connected to hydroxyl. So let's go take a look at what that would be. If we look over here, that would be a carboxyl group, and it makes you a carboxylic acid. So carboxyl group, and it makes you a carboxylic acid. So carboxyl, and then carboxylic acid. There's a specific name for this one, but for now, just know that it's a carboxylic acid. Okay, let's go over here and take a look at this molecule next. You have to be careful. A lot of students make this mistake. They take a look at this and they say, oh, that's another carboxyl group. Remember, though, it's not. To be a carboxyl group, you need to have an OH attached to the carbonyl, and you don't have an OH there. You have an H only. So this is really the C-double bond O. C-double bond O truly is the functional group here. And notice that the C-double bond O is placed at the end of the molecule. So it's not placed somewhere, in the middle. It's placed at the end. And I know that because there's an H connected to it. There's no other carbons there. It's the last carbon in that chain. And so what this is looking back at the table there, this is a carbonyl group. And when it's at the end of a molecule like that, it makes the molecule an aldehyde. Let's go to the next molecule. You'll see that we also have a carbonyl group here. Okay, so it's the same functional group as in the previous one. However, because the carbonyl group is placed in the middle of the molecule somewhere, not exactly in the middle, but somewhere not at the end, like not here or not here, then that makes this molecule something called a ketone. Now, this one looks a bit weird, this line here. What does this line mean? Well, each of these points represent some carbon-hydrogen groups, okay? So instead of drawing carbon-hydrogen groups out like this all the time, you can actually just draw them as these little zigzags like this. And I'll go over how to do that later on. Right now, just get these are carbon-hydrogen groups. And our functional group is over here. This is the amino functional group. And when you have an amino functional group, it makes you an amine. All right, now let's go to this one. We got to be careful. Attention to detail is super important here. You might think, okay, here's another amino functional group, so we got an amine. Look next to it. Look at that carbon next to it. There's a carbon double bond O attached to the amine, okay? So here we don't have a regular amine functional group. If we go to our table here, you'll notice that when you have the amine connected to a carbonyl, that makes it a carboxamide. And that would make you an amide. Carboxamide. And it makes the molecule an amide. Okay, let's see what's next. So right here, you'll notice that we have a carbon double bond O, and then a little O over here. Now we have to look at what's next to that O. Notice there's a carbon chain here and a carbon chain there. So this here is the functional group. This is the functional group right there. This is a carboxyl functional group. And you would think that it makes it a carboxylic acid, but it doesn't. One of the H's has been replaced by a group of carbon atoms, carbon chain. And so that would be an ester. We have an ester. It's basically two carbon chains connected by this carboxyl group. And last but not least, we have carbon chain over here, but our functional groups over here. This is a halogen connected to the carbon chain. And that makes this either a haloalkane, or an alkyl halide. And so what you've just done is you've looked at some simple molecules, you identified their functional groups, and using their functional groups, you classified the molecule as being part of a certain organic family. In the next video, we'll take a look at a molecule that contains many functional groups, and the family that that molecule overall would belong to would depend on what's called priority. Different functional groups have different priorities, but right now we're not really going to care about priorities too much. We're going to focus more on just being able to identify the functional groups and naming the functional groups.